Hey guys, I'm back. Just wanted to kind of show you guys what I've been working on Fusion. I know you guys have been doing Onshape, which is great. Keeping up with the foundational skills that you guys need to do, but I needed to do something where I designed and I also manufactured and machined. So I kind of wanted to break down how I was doing this. Let me go ahead and close this so you guys can get a bigger view of it. So this is my tooling to make the face shields. And my other videos, you'll see the face shield or already seen the face shield. So I've broken it down into, I believe, 6 components. Here's the base where I'm basically clamping it to the vise. I took these 2 plates, this one and this one. I'm calling them tooling A and tooling B. And I'm going to go ahead and I can turn off some of this stuff here so you guys can kind of see what's going on. So here's what the face shield looks like, and essentially what needs to happen is we're getting an 8.5 by 11 piece of transparency, and we need to add these 6 holes, and we need to put these fillets up here on the corners, so that way we don't, scratch ourselves when we put on these face shields. So a couple things I had to do is make sure that everything was nice and flat, and what I call square is 90 degrees, so that all the things bolted together in high tolerance. I ended up making these holes right here for these dowel pins. These dowel pins are alignment tools to basically take this edge and this edge, so that way I know that the transparencies are sitting in there aligned to the X and Y axis. So I have these top clamping pieces that basically get bolted down and squeeze the individual sheets of 100 and make it treat it as if it was a solid. Again, you guys will see videos of it being machined. So these larger holes here are for the bolts to clamp it down. Smaller hole here and here are dowel pins for alignment. If you guys see how I made this metal piece is actually smaller than the transparency piece. So that way, when I'm machining this fillet right here, this edge doesn't get machined every time. So I kind of gave it what I call a setback. I also relieve the thickness from this surface to this surface, so that way the cutting edge of the end mill doesn't have to be so long. So that way we don't have any problems with any kind of rubbing or wear. This bottom piece represents the transparent. You can see through it. See how that is? So I'm basically just giving myself an idea what it looks like. Bolt, again over here, a bolt, dowel pin to align everything, and then these 6 holes that I'm going to use as alignment for drilling. Again, if I take individual sheets of plastic or individual sheets of metal that are really thin or individual sheets of paper, I can squeeze them as tight as possible and it will act as if it was a solid. I'm going to go into manufacturing so you guys can kind of see what I've been doing here. I have what's called setups, and setups are giving me my X and Y origins. I can go ahead and click on this one. And I can turn on all my tools, so you can see my tool paths. I can right click, I can go into simulate, and it's going to show me what the machine is going to go ahead and do. And it's basically going to come over here, come in, drill, and that's what it's going to give me. So I end up turning on my stock, and that's what it would look like. Okay. I can go ahead and show you some of, let's see, this one. I have a lot more operations. Right click, I'm going to regenerate those operations. And now I have all of these tool paths. I'm going to come back here, turn off these tool paths so you guys don't have to look at them. And you guys can see all the different things that, I don't want to do that, cancel. Turning on all the tool paths so you guys can kind of see it. I'm going to right click, I'm going to go to simulate. I have my stock on, and then this is what the tools are going to be doing. It's going to come in, It's going to machine the tops flat. Now, I didn't machine all of this bolted in onto my tooling. I did it individual pieces. What's nice about Fusion is I'm able to machine it as if it is in place. So right now I'm doing what's called roughing, and it's changing color from green to a blue. So it's telling me all the different operations that it's doing. So this is called an adaptive clearing, where it's rapidly removing material. It's going to do that in all four corners. I'm going to go ahead and skip to the next operation. Now it's going to go around and actually make the right size. So you can see that. And then now it's going to come in here and it's going to go ahead and start drilling. And those are for my bolt holes. Same thing here is I'm going to go in. What I'm going to do is I'm going to pocket this with a really small end mill, so that way I have high tolerance for my dowel pins. And it's going to come back in. And now this particular tool is just getting rid of the sharp edges. Now it's done out of order. I'm going to go ahead and get rid of this area. Remember, I was saying I wanted to relieve that so that the end mill doesn't have to worry about cutting it. And now it's going to do what I call a finish cut. I'm not going to show you guys the entire thing, but this is the basic operation that I'm going to do. And I've already machined it, designed it. I think I approximately put in about 18 hours into it. And now I can go ahead and machine about 100 transparencies in about 1 minute. I have an order for 3,000 transparencies this week. So hopefully you guys are seeing me use the skills that Takamoto and I teach you, and I'm applying it to help out in the COVID response. All right, guys, I hope you guys are doing okay at home. And I will start turning on assignments again. I gave you guys a break while I was doing all this work. All right.